Now, in this experiment, we are going to see the study of P, Pi, Pd and PID controllers. So, in this, the aim is to obtain the response for the P, Pi, Pd and PID controller using the MATLAB software. So, in this MATLAB software, we are writing the program and we are going to check the response for the P, Pi, Pd and PID controller. So, we know we are studied in the control system that Pi, PID controllers are used for the proportional integral, then proportional integral and derivative controllers for controlling the transfer function of the control systems. So in this we are using the MATLAB software. We are going to do some programs and we are going to see the output of the corresponding PD and PID controllers. So first is the program, that is the step response for the transfer function 1 divided by s square plus 10s plus 20. So in this we are going to write the program on the MATLAB software. So the program will be like this only, that is the numerator will be the 1, that is the transfer function of 1, and denominator is 1 plus 10 20. So for s square the value will be 1, for s term the value will be 10, and for the constant term the value will be 20. For now we are going to see the step response for this controller. So this is the only for the step response. So we are going to write only the step response for the transfer function. So this is the MATLAB software. In this, so we are going to write that what is the PI controller will be given. So in this we are going to see the proportion controller, that is P, that P value will be given as 300, that is numerator will be taken as Kp and denominator by 1, 10 and 20 plus Kp. So the time duration will be T, then figure 2 will be given with the step input of numerator and denominator, and we will want to end it with a grid. So the program will be write it in the MATLAB software like this: proportional controller Kp, numerator 1, denominator T and figure with another step numerator 1, denominator 1 and T with a grid. So then after finishing the program we want to run it. So this is the MATLAB software. So we are going to run the program. So after running the program we want to wait, then it will show the step response of the proportional integral. Then for the proportional derivative controller, so proportional derivative means you want to have the Kp. So proportional will be written as a constant Kp, derivative controller will be written as the Kd. So Kp, Kd, the numerator will be having two constants, that is so denominator will having 1, 10 plus Kd and 20 plus Kp. So you want to give the time for a figure, it will have the numerator 2, denominator 2 and T, and finishing the program with the grid. So the program will be like this. So that is the PD controller. We are writing it 300 derivative 10. Then for Kp, Kd, we are writing the step input and we will finish with the grid. So now we are going to run the program. So the step response will be like this, because we are giving the step input only. So the step response will be like this. Then for PI controller. So PI means we are having Kp as a proportional controller, Ki as a integral controller 30 and 70. So the numerator will be Kp1 and Ki. So the denominator will be taken as 1, 10, 20 with Kp1 and Ki with the time T. We are doing for the figure 4. So new step up with the step input numerator 3, denominator 3 as well as with the time T, that is will be given for the T seconds. Then grid, close the grid. Grid means to end the program. So Kp then Ki controller, we are write it in the command window. Then you want to save the program and run it. So your output will be like this step response. You can see the variation from the first P controller, Pi controller, Pd controller. Then at last PID controller. So we are having three controllers: P controller, I controller, and D controller. So you are returning like a KP, KD, and KI. So that is KP for proportional, KD for derivative, KI for integral. So we are giving for the numerator three terms and denominator with 1 plus 10 plus 25 with a KP, KI, KD. Then regarding that we are giving the time, then figure with the step input numerator and denominator, and we are closing the program. The output will be see KP, KD, KI, three terms will be given, and the output numerator denominator for the step input, closing the program with a grid, and we are going to run the program. So the step response will be like this. So after writing the program, we want to save the program and run it and see the response. So this is the study of what PI, PID as well as what PD controllers. Thank you.